Yeah, hello, good afternoon, good evening almost. It's a great pleasure to be here. I'm going to present the company MaruHachi to you. My name is Michael EFFING. I'm the senior advisor to the Japanese firm MaruHachi. I think they have an interesting story to tell us today about thermoplastic composite and mass production in Japan. So it's great that you are here at the end of the JEC show, so be staying with us. We like to introduce you to MaruHachi, and I think we first start with a video. So this is a factory of MaruHachi in the Fukai region. It's a tradition of 3 generations, starting with the textile industry. In 1936, you will see here this young CEO, Toshi SUGAHARA, who took over a textile operation and is one of the pioneers in Japan for thermoplastic, but also for Thermoset prepregs. So you see early on fabrication and knitting with glass fiber and carbon fiber. And now moving into thermoplastic composites. And the CEO, Toshi SUGAHARA, will explain this in detail in a minute. Okay, so I'd like to welcome Toshi SUGAHARA, the CEO of MaruHachi, who will give an insight of the family background. So he's in the 3rd generation. The company started in 1936. He took over from his grandfather in 2018 as a CEO. And Toshi, you're very welcome here. I will be with you for the, hopefully, discussion and Q&As at the end, and I'll let you explain the story about MaruHachi.
Okay, thank you, Michael. Hello, it's very nice to be here, and thank you for coming to the our introduction of my company, MaruHachi. So I'd like to say a few words of our company history. So we started our company in 1936, so it's almost nearly 90 years now. And we started the composite business in 2002. So it's nearly over 20 years now. And we also had the JEC award in 2014 for the high pressure vessel. Yes. Now, I'd like to introduce our way of proceeding in development and production in composite. So this is already you know very well, but I like to explain our flow of the how we work with the how we start the development and the production. So firstly. Pointer. Okay, so firstly, we get the client idea and of the requirements to think about. Then after that, we will discuss and also make some design optimization. Then we will come to the material to select, or if we don't have, then we will develop. It could be sometimes in-house or outside. And also perform, also select or develop in-house and outside. Then finally, we select the process from the lots of candidates. Then finally, we start production. This is how we work in the composite flows. Okay. And so especially in this flow, we have the 3 processes like design and the analysis process and material process and preform process. So I go into a little bit of detailed introduction of these three processes. Okay. So we have the CA analysis process with the experience from the high pressure vessel as we had the JC award in 2014. So it's like more than 10 years we have been working on the CA analysis. And also material process. We have the ability of the reinforcement and also prepregs. Then we will make the evaluations and analysis on the material. Then preform, for example, like a laminates or tailor blank. That's what we do. So it sees like there is a one-stop development process. And then finally, we have also set up the ability to mass productions. Okay. So yes, here is the my colleague will explain for this.
Okay, my name is Hiro, R&D section manager of MaruHachi. So this slide, no. Sorry. Yes. First, we start to the composite design based on the CAE analysis. So, to make the composite parts, this case is making of housing facilities, countertop, bracket. So, customer needs customer needs is here. So, want to have a space under ground top. The bucket should not be visible on the right weight. So we evaluate visibility evaluation. So by also CAE. So we also analyze mechanical behavior by CAE, optimize the shape of the composite parts. This is bracket. So finally, we can suggest how make it material and preforms and molding process at all. So fit to spec of customers. So we ready to discuss and develop composite parts together with you. Yes, just change to Toshi.
Okay, thank you. So, okay, thank you. So I back to the our process explanation. So as we said, we have the material process of the reinforcement. So in reinforcement, we have two sections, like one is woven and another one is knitting. So we have the woven fabric capacity and also the knitting fabric capacity for reinforcement. And also in prepregs, we also produce the thermosetting prepregs and some plastics prepregs. But in case of the European market, we really like to introduce our some plastic prepreg. What ATEX? It seems very hard to pronounce, but it says ATEX for our brand. And we also have the two types of the some plastic prepreg divided by the matrix. So middle temperature, it's like engineering plastics matrix is middle temperature types. and also the high temperature type for like PPS and PEEK. So we have two kind of the unidirectional prepreg tapes or sheet. So in case of middle temperature, we have the maximum width is 1 meter, so which is quite big, and also the continuous load to the up to 500 meter or 1,000 meters. Okay, so this is our material process. Then pass to the again to my colleague Hiro.
Thank you. We can evaluate any behavior of composite parts in-house. So in case of viral, you can see the upper figure shows about impact resistance of the composite. We are checking for the functional availability of composite laminate. So, for example, also you can see the result of our modified material. So, has a higher impact resistance. You can see that. In case of ATEX, we also check the mechanical properties of mechanical testing in-house. We check the quality of laminate. So our team is able to discuss everywhere about hypothesis, the mechanism, and etc. Regarding this quality or behavior. So, the evaluation the properties was with you, sir. Okay. Change to Toshi.
Okay. So again, I come to the process of the preform. So in case of preform, especially for the some plastics I'm introducing here, is we have the automation layup system and a press molding system for laminates. And on the right-hand side, we have the tape layup system with the laser assisted, so we can have the ability to make the tailored blank and also the ATL layup material. So as the preform, we mainly produce the laminates of the unidirectional layups and also the fabric layups. They are also using the tape layup method to make the tailored blank to the final items, which is made by our client or a collaboration with our client. Okay. Then we have decided to invest the. I mean, we started investment for the this preform process to up to the mass production. So here it says like our capability of the auto layup system is, for example, like a 1.3 square meter of the laminates with the 200,000 pieces per year. Also, we have the multiple press system, which is also have the same as the same capability of 1.3 meter square with the 200,000 laminates per year. And also, we have the NDI system and water jet cutting for cutting of the materials. Okay, so now we are again we can have the ability of the one-stop development and also the mass production capability. And yes, That's what I really like to introduce our capability. Yes. So this is the final page. Thank you very much.
Yeah, thank you very much, Toshi, for the presentation. And also to you, Hiro. I think the key message is here, there are new capabilities in Japan making tape-based material and also tape-based laminates on high-performance polymers, PEEK, PEI, PPS. And I think we have probed a little bit, or you have probed the market in Europe for polyamides and polypropylene, but this is not, let's say, a value proposition from making products in Japan and shipping them to Europe. So you're focusing on producing these parts and elements in Japan.
Yes, in Japan at the moment, yes.
And what are the key markets that you are targeting?
So we will start with the sports and leisure market firstly, then move into the more industrialized applications.
Okay, very good. Are there any questions in the audience? Okay, maybe if there are no questions, maybe a final question from my side.
Yes.
When do you think this will be in full production for maybe a sporting good application? Is it already next year?
Yes, actually, we will complete our installing in by end of this year. Then we will take some trials and kind of the what is it? Testing time is like 1 to 2 years. So maybe in 2025 to 6, we will start the production.
Good. And thank you very much. I think it's already late. Thanks for coming here. And please see us maybe tomorrow at the booth. The number, it's just outside here of the hall,
Yes.
in hall number 6, and we can talk more. Thank you very much, and bye-bye.
Thank you very much.
Thank you very much.